Students, we are learning about refraction of light, right? What is refraction of light? It is bending of light. Now, what is refraction of light? It is nothing but when light travels from one medium, transparent medium, to another transparent medium, at the interface where the two medium meet, that particular place, that particular position, when light incident at that place, it changes direction due to change in the its speed. When light travels from first medium to second transparent medium, its speed changes. Due to that, its direction it changes. Okay, or generally for common people you can say it is bending of light when light travels from one transparent medium to another transparent medium. That we have studied. Now we also studied the two laws of refraction. The first law says the incident ray, refracted ray, and the normal drawn at the point of refraction all lie in a same plane. The second law of refraction is Snell's law. It is also called, according to this law, the ratio of sine of I, angle of incidence, and sine R, the angle of angle of refraction, that ratio is constant, which is called refractive index of the second medium with respect to first medium. It is also expressed taking the speed of light. It is the ratio of speed of light in first medium to the speed of light in the second medium, and it is constant for given pair of medium like air and glass, air and water, water or glass, etc. Okay, and you have seen that value, the refractive index value, more it says the speed of the light decreases in that particular medium, the number you will get more. Okay, now today we will learn the refraction through the glass slab, because we should know when light traveling from denser medium to rarer medium, or it may be traveling sometimes rarer medium to denser medium. I am talking about optically denser and optically rarer medium. It is slightly different. Yesterday I said, right? So now imagine or now consider light is traveling from rarer medium, air here, and it is traveling through the glass slab. So from rarer medium to denser medium. Here again air. So from rarer medium, optically rarer medium to denser medium, when light travels, whether it will move towards this normal line or away from the normal line, we should learn. And now light is traveling from this medium, denser medium, to again it is moving towards, refracting towards the rarer medium. So what about these two angles, this angle and this angle? What the change takes place, whether it will move away from the normal or towards the normal, because it changes direction due to reflection. That we should know, right? So I have used this diagram to explain. Before that we will see the activity, how we will get it. Okay, and using this glass slab we can do the activity, interesting activity, which you will see while doing the experiment. Okay,
I am passing the light from here, and you can see the reflected light here. Can you see the reflected refracted ray? Not reflected, refracted ray here. I am passing the light here. Now if I will show you, light is passing here, but actually after refraction the direction is changed now. Can you see here? The light is going along this direction. Can you see? Here light is going, but after refraction, direction of light straight line means like this way, but after refraction it is going from this side. It is not along the same straight line. Straight line means along this side it should go light, but now the direction of light is here after passing through the glass slab. So it is deviated, it is changed its direction due to refraction. Okay, students, Using refraction of light, we can do one activity. This is candle, this is its flame. They are not joined together, right? But we can make it join together using refraction of light. Just I will keep the candle and the candle, I will keep the glass slab. Okay, now if you see the flame now, it appears to be together. It appears to be together, right? In one single piece. Base candle and above is a flame, you can see. But actually they are not together. They are not together. Can you see the difference? This is due to refraction of light. Because when you keep eye like this way, light is traveling here from the candle. But from the flame, light is traveling from the air. Here light is traveling from the glass. So when light travels through the glass, bending takes place. So due to that bend, it shifts here and it appears to be single piece. That is the experiment. Sheet, drawing sheet, the glass slab, and mark its boundary. Okay. Then take two drawing pins, insert on the drawing sheet obliquely, not perpendicular to the glass slab. Two pins. You have to insert it. Okay. Then you have to see on the opposite side of this glass slab, it's a shadow. It's image, not shadow, image. From this side you have to observe. Now can you see the image of these two pins? Now along the same image you have to insert two more pins, drawing pins, so that all lie on a straight line. You have to insert two more pins along the image of these two pins, so that all four lie in the same straight line. And we will mark the position. We will take the pins and mark the position, first two pins and the next two pins. Then we will join the straight line, that is the incident ray, and this is the emergent ray. We will join the two more pins by straight line. Now if you observe, they are not straight line. Can you see? According to the linear motion, it should travel straight, but it will move, it will lateral shift takes place. Can you see? Actually here the change in the position takes place. We'll draw it properly. You can see it. See now, here the change in the direction takes place. Is the incident ray. Here the refraction takes place, and here. That is the reason we'll get like this way.
Now I have drawn the boundary of the glass slab ABCD, that is the boundary of the glass slab, and E and F are the position of two pins. You have to obliquely keep these two pins on one side of the glass slab. Then come to the opposite side here, and you have to bend and see the image of these two pins, drawing pins, on the opposite side of the glass slab, and you have to insert put two more pins, drawing pins, seeing the image of the first two drawing pins, here G and H, so that all, when you bend and see from this side, all appears to be in a straight line. For your eye it appears to be straight line. The two pins and its image, the two more pins which we inserted. Okay. Now if you take this two pins and if you mark the line like this way, you got this figure. Okay, this is the actually rays traveling in this direction, because when we can see the pins, because light should fall and it will reflect, then only we can see the pins, right? So light is traveling along this direction, and when it come through the glass slab outside, it is moving along this direction. And even though when we see the two pins, it appears to be straight line, actually they are not in straight line. If it is straight line, this is the linear movement of the motion of the light, that ray of light, it should travel along this direction, straight line. If light is traveling a linear motion without changing the direction like this way, it should be traveling like that way. But actually, it is traveling from here. From this position to this position, the lateral shift took place actually. Due to refraction of light, lateral shift from here to shifting of light has taken place. In the same direction, it is moving in the along the same direction, but the shift in the position is took place. Light is traveling along downward only, like this way only, when it passes through the glass slab also, but see the position of the ray from actually should be like this way if it is straight line traveling, but in reality it is actually shifted to this position. This is due to refraction of light. Okay, and if you see the figure here, now here this is the incident ray, this is the normal. At the point of refraction I have drawn the normal n and dash, and this is the angle of incidence, I angle, right? And this is the refracted ray, this is the, sorry, not this one, this is the refracted ray, and with the normal it will make an angle which is nothing but I. Now if you see I and R, I angle is bigger and R angle, angle of refraction is smaller here. Now light is traveling from rarer medium, air, and it is traveling to denser medium. Now see the ray, refracted ray, it come closer to the normal. It is away from the normal in the rarer medium, but in denser medium, it move towards the normal line. So what you will say? You remember when the light is traveling from first medium, which is rarer medium. So light is traveling from rarer medium to denser medium. The refracted, the ray will move towards the normal. The ray is moving towards the normal. Okay, it is not the ray, it is the, just to show dotted line. If it is moving straight line, I have shown this line, don't see this line. Okay, now this is the denser medium, this is the refracted ray. Okay, this is the refracted ray at O and O dash, that the change in the direction takes place. This is the point of refraction. Okay, now if this is the refracted ray. Okay, now here the medium again changes. First medium, second medium, again it changes. So once again the change in the direction takes place because speed of the light changes, the bending takes place. Now if you observe here, now this is the incident angle. If you consider one more setup, one more example, if it is considered incident angle, this will become the angle of refraction for this set. Don't see here. Now imagine light is traveling from, this is the first medium if you consider glass, and air if you take the second medium, the light is traveling from denser medium to rarer. It is denser medium. Okay, denser, and this is rarer. Air is rarer. Optically it is rarer. For light it is denser, this is rarer. Okay, so light is, now if you see, this is as the first ray, first medium, light is traveling in the denser medium and it is moving towards the rarer medium, air. Now see the, this is angle of incident, I dash, then, and this is angle of refraction, R dash, R dash, I dash, R dash. Now here, see here which value is bigger, I or R here. R is bigger, right? And I is smaller. And if you observe here, this ray after refraction, it will move away from the normal. It will move away from the normal. Okay. So it is in generally in a glass slab we will have incident ray, refracted ray, and we will call this as a emergent ray. It is emerging from the glass slab. Okay, it is the emergent ray. And here two times refraction takes place. One time here and the second term here. Here 2 medium will change and here 2 medium will change. Air to glass, light will travel. Glass to air, light will travel. Here from rarer medium to denser medium, light is traveling. Then always remember, light bends towards normal. And when light travels from denser medium to rarer medium, it will move away from normal. Okay, so rarer medium to denser medium, I is bigger, R is smaller. Denser medium to rarer medium, I is smaller and R is bigger. Okay, I is small and R is bigger. This is a thing we have to remember. This experiment help you to understand that whenever light travel from denser medium to rarer, which way it will move, whether it will move away or toward the normal line, you come to know. Okay, and you also observe here through the glass slab, lateral shift in the position of the ray takes place due to refraction. 2 times refraction takes place. That is the experiment, refraction of light through the glass slab. Okay, children. Next one we will learn about the lenses. Before that, you just observe yesterday in the activity, not activity, here extra questions, we haven't did 1 or 2 questions, right? Page number 86, extra questions. A ray of first question, a ray of light traveling in air enters obliquely into water. Does the light ray bend towards the normal or away from the normal? Why? Here, from air to water, light is traveling, right? Air is rarer medium and water is denser medium. So, rarer medium to denser medium, light is traveling. So, light ray should move towards the normal or away from the normal. In denser medium, it is always move towards the normal. So the answer is it will move towards the bend towards the normal. And why they are given? Because water is more denser than air. Then second question we are not did. Light enters from air to glass having refractive index 1.50. What is the speed of light in glass? They are given speed of light in a vacuum, or instead of air they are given vacuum. It is 3 into 10 to the power of 8 meters per second. That one we will do before proceeding. So speed of page 86, second one, speed of light in vacuum. Speed of light in a vacuum, they are given 3 into 10 to the power of 8 meter per second. Then speed of light in a, you have to find, therefore. What is one more thing they are given? Refractive index of a glass. Refractive index of glass. It is 1.50. Therefore, speed of light in glass. Refractive index is equal to speed of light in vacuum and speed of light in glass. So speed of light in vacuum is given 3 into 10 to the power of 8 divided by speed of light in glass. It is refractant index given 1.50. If you bring this side here and if you move this side, 1.50 is same as 1.5. Okay, so I'll write 1.5. Now if you bring this here, it is 1.5 into speed of light in glass is equal to 3 into 10 to the power of 8. You want speed of light in glass is equal to 1.5 into, bring this side, it will change into divide. So 3 into 10 to the power of 8 divided by 1.5. So 1.5, 1 time 1.5 into 2 is 3. So it is 2 into 10 to the power of 8. So it is 2 into 10 to the power of 8 meter per second. That is the speed of light. It decreases in a glass because it is denser medium compared to vacuum. Vacuum is the highest, least rarer medium where refractive index is least there. Almost 1 it is. Okay. So that is about the extra questions. Next you are going to learn more about the lenses. We have seen the lenses. This is the lens actually I am wearing. The spectacles we are using. This is lens. And you have seen the detectives, the watch repair, etc. They will hold one glass. I will show you in the next class. That is this one. Magnifying glass, you will say it is magnifying glass, that is also lens. In a telescope, what is telescope? To see the at night they will use the instrument, optical instrument, to see the planets or stars, etc., which is called telescope. To see the faraway objects, celestial objects, the optical instrument is used, that is called telescope. There it is, that is also lens they were using. And when the cricket match is going, you have seen cricket match is going now between Australia and India, right? And if you are far away in the stadium, cannot see clearly the players, they will use binoculars, or the bird watchers, those who are studying about birds, they will use the instrument, optical instrument called binoculars. There also the lens is used. And to see the microbes, okay, they will use compound microscope. There also we will use the lens. So everywhere we will use lens and lens, that in optical instruments, even in our eye, the camera that contains lens. Now what is lens and what is its uses, and what is the refraction of light through this lens takes place, how it takes place, and what is the image will form when light passes through the lens, that all we will study now. Okay, so one by one we will study. Just today we'll see the two types of lens mainly. There are many types of lens are there. Lens are transparent glass material, which is not plane. Okay, the surface is not plane. It is maybe bulged outside, both side, or it is bent like a cave inside. Both side, it is double side also, this side and this side, it is bulged outside. This is one type of lens. And in this one, cave is, cave structure, right? So it is bent inwards. There are other lenses also there, we are not studying it. Only one side it is bulged outside and other side it is plain. Or it may be one side like this, one side concave, cave like structure and other side plane. This type of lens also there, which we are not studying in this class. We are studying only double sided, bulged outside and both side cave inside. Now this is the convex, double actually we won't use the word, usually we will say the word convex lens. Okay, this is convex lens and this is concave lens. And how to say whether the transparent glass is convex lens or concave lens? Just by holding it you can find out. One method is touch the surface. It is thick at the center and thin at the edge. Okay, and in a concave lens it is thin at the center and thick at the edge. By touching you can feel. Okay, I will show you the lens, the two types of lens. This is the convex lens. Can you see? This is the convex lens and you have to touch here. If you touch at the center here, you should touch to feel it. It is thick, and at the edge here, at the edge it is, if you touch this one, it is thin if you touch. And we have another lens, that is concave lens. We have here, this is the concave lens. If you touch here at the center it is thin, and at the edge, here at the edge it is much thicker. And another way you can find out this convex lens or concave is, you just, convex lens is magnifying glass, here it is used, and if you just observe here, this one, the books writing, it looks bigger. And if you see through the concave lens, if you see through the concave lens, it appears to be smaller. It appears to be smaller. If you have the your at home, your parents may have the glass, it may be concave or convex lens. To remove the defect of eyes, we will use the lens. Some of them, those who have short sight, those who cannot see and the closer things only they can see, those who cannot see far away things, they will use the lens, it is concave lens. Okay, and those who have the problem, far away objects they can see, but nearby objects, foresight, hypermetropia, the people like Charlies, they will wear, no, that is convex lens. So by seeing that, you will at home you can see whether it is convex lens or a convex lens, and how the refraction takes place in a convex or a concave lens. That we will study in the next class.